Fresno State students, some of whom are behind me, are proving that physics can be fun, and they're taking their message to children and teenagers throughout the valley. Joining us with a quick lesson are Don Williams, he's a lecturer at Fresno State, and physics students Simon Gonzalez and Brian Emerson. Good morning to all of you. It's so good to see you. They're so excited about physics that they're even making me like physics, and I thought it was so difficult and hard to understand. You've brought some demonstrations along. These are the kind of demonstrations, Don, that you take to the valley's kids, right?
Absolutely, absolutely. Yeah, I have actually a total of 5 students.
Got it.
And we go to any kind of school that you can imagine, from elementary to high school, and we get them excited about science.
Why is that so important?
Because we don't have enough people in science, and we don't have enough good science teachers. And Alex, we also try to promote females in science. Actually, my colleague that co-teaches it, she's a female, Pei Chun Ho.
Wow.
Yeah,
okay.
absolutely. She's a little camera shy, so she didn't really want to come today. But yeah, we have a lot of fun, and the kids get a lot of energy out of it.
I can tell. Okay, let's get started with some of these demonstrations because there are several of them, and I want to get through all of them. All right, Simon and Brian, what's the first one that we've got here?
Okay, we're going to be doing the bed of nails here, and I'll be demonstrating pressure with it, okay? So I'll do a little quick example with this apple right here.
Okay, got it.
So this apple right here, I'm going to drop it at a certain height, and it's going to have a force. When it hits that bed of nails, the area of which it hit was very small, so its pressure is very high. So Brian here is going to demonstrate how to lay on a bed of nails.
They wanted me to do this, and I would have, but you know, I've got a pack of microphones behind me.
So Brian's sitting down on this bed of nails, and as you see, his force is very small, and his area around the bed of nails is very large. As he lies down on it, he keeps that low force, and his area increases. He does not get impelled by those nails because he has a very low pressure. Good job, Brian. You could get up.
So that's what they're learning here?
Yes.
Okay.
We explain all the physics of that, and we do these great demonstrations. They get so excited when they see this.
Do they lie in the bed as well?
Yes, they do.
Oh, that's amazing. Did it hurt, Brian? No? You sure?
No,
okay.
quite
You're not tearing up or anything?
No.
Okay, fantastic.
When we go to grade schools, Alex, every grade school kid has to try it, of course, right? Oh, yeah, sideways, front ways, whichever way they can.
Okay, this is the next demonstration. Brian's going to work on that for us.
We'll use this to demonstrate atmospheric pressure. It's very similar to the pressure we did there, but the weight of the air all around you kind of adds up to about 15 pounds per square inch, and this is a square foot. So the atmospheric pressure would push down about 2,000 pounds on this little suction cup square that we have here, and we're going to put it on the stool, squirt all the air out, and when that air comes out, now the lower pressure between the pad and the stool is smaller, and so the atmospheric pressure allows me to just lift that stool up with the hook. It's not glued on or anything.
Wait, this is not magnetic?
Nope. Go ahead and lift it up. When you let the air in,
okay, yeah, I see.
when you let the air in, the pressure normalizes and it comes apart. That's how suction cups work.
Okay, got it. Perfect, perfect, perfect. Okay, now you wanted me to spin around.
That's next.
Okay,
Coming up. You can watch Brian do it once, and then we're going to let you do it.
I want to participate.
Okay, great. And we want you to participate. So Brian's sitting down on this stool right here, and I'm going to give him these weights. Here you go, Brian. Okay, now why don't you stand back here because he's going to be spinning around. So I'm going to spin Brian around his axis of rotation right here. He's going to send these weights out, hold them out like this, and his rotational inertia is up high when he has them out like this. So when I spin them, I'm going to spin them up right here. And you can see he's not spinning that fast, but when he brings them in, his rotational inertia goes down, he speeds up.
So like an ice skater.
Exactly like an ice skater.
Here's your set.
Okay.
Okay, are you ready?
I get lighter weights.
Okay, sit down and make sure your feet are on this bar on the bottom.
This one?
Yes.
Got it.
Okay, hold those weights out, and I'll spin you around.
Oh, God.
There you go. And I want you to speed up, so what do you have to do? Bring in those weights.
Oh, this is so fun.
And you slow yourself down by bringing them out.
No way. This is so fun.
Oh, the kids love it. They get so excited when they're doing it.
I've never... Okay, I'm going to do this at home with my kids. This is so fun.
Yeah, he'll love it.
Gotcha. Okay, more demonstrations.
Yeah, we use liquid nitrogen, which is about negative 200 degrees Celsius, so it's really, really cold. And we'll put things in it and kind of see how that changes the states of matter.
Okay.
So we took a balloon, we filled it with air, tied it up into a little knot so the air stays there, and we put it in here and it condensed the air. So it made the air like really small. As I bring it out, the air warms up and the air expands and it fills up the balloon again.
So all you did was you took a balloon, you filled it with water, you put it in...
Blew with air. Just blew
air. Okay, got it. And you put it in dry ice, it shrunk, and now with the warm air, it's opening back up again.
Liquid nitrogen. Yeah, we put it in there and it broke it, and it aired it back up. We also show with different properties of the balls, like a ping pong ball. In here, it bounces just like a regular ping pong ball. But with a tennis ball, as this bounces, this one is like a rock. It's really solid. And then lastly, we took a racquetball, And when it gets super cold, its properties change considerably. And it breaks.
That was
like
a
glass.
racquetball?
That was a racquetball.
Oh my goodness.
Breaks just like glass. So one other really cool thing about liquid nitrogen, since flowers are made of water just like our bodies, it freezes the water inside the flower. And normally I could hit the flower and it's fine, it won't break. But a frozen one just shatters.
So that's liquid nitrogen in
Liquid
there?
nitrogen, yeah.
Okay, got it. Oh my goodness.
That's a
don't wanna
lot
stick your
colder
hand
than
in
dry ice. A lot colder.
And it no wonder, because this is frozen.
Yep.
And then you stuck it in there for just a couple seconds.
That's it.
Wow, that's crazy. Okay, is there more?
Yeah, we're going to do a Bernoulli effect here real
We
quick.
have about
You
a
probably
minute and a half.
All
so
right,
that's
perfect.
1 minute.
Okay.
Wow. Now, what is this teaching kids?
This is teaching the Bernoulli effect, all right? And now this is something we don't usually like to show, but this is how you can toilet paper in the house, too. So now you know how to get the toilet paper way up in the tree, but don't tell anybody we taught you that.
Okay,
President.
got it.
All right,
yeah,
exactly.
We don't want people to
Absolutely. And since we got a minute, bring that ice cream over real quick, guys. And let's pour some liquid nitrogen. Brian, you grab the...
And while they do that, I do want to mention that they do, as we talked about at the beginning of the segment, travel to different schools throughout the valley. So if you are a teacher or you are an administrator and you
There's a
want
glove
them to
over
go
there
to
as
your
well.
school, please let them know. You can contact Nancy Wright at 278-6652, 278-6652. Ask for Nancy Wright, and maybe you can set an appointment
Absolutely,
to go over
absolutely.
to the school. Now, what are they doing?
We make ice cream by taking half and half whipping cream and brown sugar, because that really adds to it, and we pour the nitrogen right in it. And we'll have ice cream in about a minute. We're at home, how long does it take?
Kidding,
Yeah,
no
it's very,
kidding.
and we always do this at the end of the show. All the kids get free ice cream.
That is great.
And
Okay,
they
so while
absolutely love
that's getting done, my producer's asked me to please tell her how the magnet works.
Yes, the magnet is actually a superconductor, is
Okay.
what it is. And when you get it really cold with liquid nitrogen temperatures, which I'm pouring liquid nitrogen in there, then if I put a magnet on top of it, it actually expels the magnetic field. Well, I don't have it cold enough now. We had it cold enough a minute ago.
And that's why it was floating on the air
Right,
like
because
that?
it's a superconductor, and a superconductor, what happens when you get it at cold temperatures, the resistance goes to zero, so electricity flows freely. And so we actually have this effect called the Meissner effect, where the magnetic fields are expelled from the superconductor, so you can actually elevate a magnet on there. There we go.
Oh, there it goes.
There it
There
goes.
it
There's our
goes.
magnet. You see it spinning? Can you see it spinning too?
I can.
Absolutely.
That is fantastic.
And we would love to make that application to high-speed rail trains that come through the valley. Elevate the trains, yeah.
Try some of that ice
You
cream.
Yeah,
guys
try
are
some of that ice
geniuses.
cream.
Okay, you've
You're
just
gonna
made
love
this
that.
right now.
Oh,
Reminds me of the little dot ice cream.
Right,
That's
isn't that
so
good? Isn't that
Oh my
good?
goodness, that is
Low cal.
delicious.
It is. It's very good.
Thank you so much for being here. This was so much fun, everybody. We sure appreciate it. Remember to contact Fresno State and have them come over to a classroom near you. Stick around, folks. Coming up here on Central Valley Today, making slightly used furniture.